If you are watching this video from home, make sure that you pause right now and try to work these problems. And so we've had some time in class to do that. Now we're going to go through and work them together. All right, number one, what's the first thing you always do with a limit? Substitution. And so when I plug in 0, I get -5 times the cosine of 0. Cosine of 0 is 1, so just -5. Any questions about that one? On the second one, we're going to factor. You try plugging in b, of course, and you get 0 over 0. So I'm going to factor the denominator. Would you agree it's a difference of perfect squares? What is the square root of x to the 6th? Good. X cubed minus b cubed, x cubed plus b cubed, which works out really nice because I have x cubed minus b cubed on top. And then I can plug in b now, and I get 1 over b cubed plus b cubed, which is 1 over 2b cubed. Okay, any questions about that one? You can. If you did L'Hopital's, the derivative of the numerator, so same problem with L'Hopital's, is 3x squared, the derivative of the top, so we're doing the limit as x approaches b. On the bottom, the derivative is 6x to the 5th. Where in the world did the b's go? Right, they're just a number b, so the derivative of a number is 0, even if it's to a power. This does reduce to 1/2 x cubed, or 1 over 2x cubed, and then the limit as x approaches b would be 2b cubed. So either way you get the same thing, L'Hopital's or factoring. Same thing on number 3, you could use L'Hopital's or factoring. I have this written on the next slide. I actually have both of those, but I'm running out of room. So number 3, one option is conjugates. That was the only option before L'Hopital's. You do have L'Hopital's as an option also, so if you did it that way, that's great too. Multiply by the conjugate of the numerator, and I get 4 minus x. You do need the parentheses around the 4 minus x. On the bottom, you have x times that conjugate. On the top, things cancel, and you just get a plain x on top. The x's then cancel. Then you can plug in the 0, and you get a 4th. So that's the work behind number 3. The other option, of course, is L'Hopital's. I want to see it with L'Hopital's. The derivative of the numerator, the derivative of 2 is just 0. Then you have -1/2 times 4 minus x to the -1/2. Does everyone agree? Times -1 over 1. And then you plug in 0. 4 to the -1/2 power is 1/2. 1/2 times -1/2 is -1/4 times -1, which is 1/4. So L'Hopital's have a yucky derivative, but it's a little faster if you know L'Hopital's. Any questions about either option? Technically, AB students don't know L'Hopital's rule, but you do. And it is allowed on the AP exam, even though it's not actually in the curriculum. Okay. Number 4. I'm approaching infinity, so I'm going to look at the highest powers on the top and bottom. -6 divided by 2 is -3. Done. Stop there. You also could have used L'Hopital's rule. It's in infinity over infinity, so L'Hopital's rule is an option. Another x is approaching negative infinity this time. The highest power is the cube on the bottom, so that means we are approaching 0. I hope you're kind of starting to like the ones that approach infinity, because they're usually minimal work. This one, as x approaches infinity, y approaches infinity also. Any questions about that? The top is bigger, and 3 times a really big number divided by a not so big number. It's a really big number. This one's a tough one as far as approaching infinity goes, and it is a common question they ask on the AP exam. I know that the square root of x squared is just x, so I know that this approaches 3 of some sort. Does everyone agree with that, the ratio of the leading coefficients? But because the top is negative and the bottom is positive, what am I going to be approaching? Negative 3. Does everyone know why the top is negative and the bottom's positive? The top is being multiplied by that big negative number, but the bottom is squared before it can be square rooted. Does everyone see that? So when you square it, you lose the negative on the bottom. The negative's on the top, but it's not on the bottom because of the square. Does that make sense? So that one's tough, common, keep it in mind. Limit as x approaches 1, when we have a piecewise, we have to plug in 1 into the top and the bottom piece, since that's the break point. And so on the top I get e to the first, on the bottom I get e to the first. Are those the same thing? Then that's the limit. If they're different, then the limit does not exist.
So the limit's just e?
Yep. E to the first power. Number 9, which grows faster, e to the x or x cubed? Oh. And would that be a positive infinity or a negative infinity? Try it with some numbers. Why? The bottom's always going to be negative, right? Oh, wait, no, it's not. Yeah, it is. That's positive infinity. If it were negative infinity, it would change the whole game, too, because the e would go to the bottom, but the bottom would be positive. All right, what about this one?
Oh, you multiply.
Good. You can multiply the top and bottom by 3 and 4, if you wish, and group it. You would have to group the 4 with the sine of 4x. That limit is 1. And then you'd have to group the sine of 3x with the 3. That limit is 1, so you're left with 3/4. That's the prior to L'Hopital's rule option, right? What if you don't remember how to do that? L'Hopital's rule. Cosine of 3x times 3 over sine of 4x, or cosine of 4x times 4. What is the cosine of 0 on top and bottom? Either option works great. What kind of limit is this? It's a derivative in disguise, right? Isn't it? Thank you. Sorry about that. So f of x is sine of x. The a value is pi over 2. So I really just want the derivative at pi over 2. And I'm writing down more than you probably would write down on an open or on a multiple choice AP exam. But cosine of pi over 2, which is 0. Okay, so this is f of b minus f of a over b minus, right? So what's the function? It's sine. What's the x value? It's pi over 2. So this really just means the derivative of sine of x at pi over 2. Now, is this the only way to work this problem? You could also use L'Hopital's rule.
Could we have used that one rule that we learned at the very beginning of limit of the x plus h minus the x derivative?
F of x plus, well, that's what we are using. We're using, hey, this is a derivative. We are using the fact that it's a derivative to say, oh, I know a shortcut to find that derivative. I don't have to do it the long way. All right, so that was a limit review. Now we're going to grade our AP packets and tests on Monday.